Okay, welcome back. This is going to be page 5 and 6, and then page 7 is going to be that graded exit ticket that you're going to complete on your own and turn in. So in statistics, A or B, well, we really have two different ways to think about the word or. You think about you go to like Starbucks or Dunkin' Donuts or something, and they say, do you want coffee or cream? They really mean, do you want coffee or cream or both in your coffee? But no one just drinks normal coffee anyway anymore. It's frappuccino, latte, mocha, hucha, matcha. I don't even know. I don't understand, but don't get me started on that. Whereas if you go to a restaurant, they might say like, "Do you want fries or what's another side you would get?" I don't even know. This is embarrassing. Do you want fries or all right, soup or salad? They're talking. Do you want a soup or a salad? Not both, just soup or salad. So now that I've gone completely off topic, uh, for us in stats, A or B means A or B or both. We're really using that Starbucks or that Dunkin' Donuts definition. They mean one or the other or both. So I'm going to show you two different symbols that we use for or and for and. Up until now, we've just been using the words. Or we represent with a union symbol. So this is the probability of A union B. That's not the letter U, it's just a symbol. And is represented by the intersection symbol of A intersection B. So you can see them written better down here. This is intersection, this is union. So if you see the intersection, that just means and, union means or. So what we're trying to do here is take the Venn diagram and shade where in the Venn diagram is the intersection of A and B. Oh, this is obvious. This is very easy. This is just the intersection. A or B, remember, means A or B or both. I should have labeled this event A, event B. So event A, event B. A or B or both. That means it could just be A, could just be B, or both. So it's going to be all of that area inside the two circles. All right. So now what we're going to do is we're going to take this information with the and the or and start creating Venn diagrams, two-way tables on a situation, and then answering probability questions that follow. So here goes. In an apartment complex, 40% of residents read the USA Today, 25% read the New York Times, 5% read both. So we got 40% read the USA, 25% read New York Times, and then we have 5% both. Suppose we asked a person at random. Again, we already know why we have to ask a person at random. Part A, make a two-way table. So I really have two events. Reading the USA Today, reading the New York Times. So I'm going to start by doing a two-way table with that in mind. All right, so I have New York Times, not New York Times, complement, total. USA Today, not USA Today, total. 40% read the USA Today. So the total of that row is 0.4. I'm just going to use decimals. You could use percentages, but when I find probabilities, for me, it's just easier to have the decimals. 25% read the New York Times, and 5% read both. So 0.05. Don't put 0.5 there. Some of you are going to do that, 0.05. So at this point, you should be able to fill out all the missing spots in this table. Go ahead, pause the video and do that. So at this point, I know this is 20%, this is 35%. The whole probability has to add up to 1. So if this is 40%, 60%, you could do this a bunch of ways. 25%, this is 75%. 20 plus 40 is 60. That's table's done. So there's a two-way table. Venn diagram just comes from these four numbers, just what's inside. I'm going to take those four numbers and fit them into a Venn diagram. So part B, you need the rectangle because that's going to represent all of your sample space. So if I do the same thing, New York Times, USA Today. Both, or the intersection, that's going to be the easiest. Neither is the second easiest in my opinion. 40% read neither. Okay, New York Times. What percent read the Times but not the USA Today? So I'm just focusing on this column here. That would be 20%. Because remember, overall, 25% of people are reading the Times. So that the 20 plus the 5%. On USA Today, but not the New York Times, overall there's 40%. So there's 35% that just read the USA Today. That's how you get your Venn diagram. So that's part A, that's part B. Part C. Find the probability that the person reads at least one of the two papers. So probability of at least one. That means they read one or the other or both. So again, at least one means they read the New York Times or the USA Today or both. So this is just really asking what's the probability they read the USA Today or the New York Times. One or the other or both. So all I need to do is sum up these three probabilities, whether it's in the Venn diagram or the two-way table. 0.2 plus 0.05 plus 0.35 is 60%. Those of you who are very formula-based, if you want to use the formula that we showed you earlier in the lesson, the probability they read the USA Today is 40%, plus the probability they read the Times is 25%, minus the probability of both, 5% is 60%. Doesn't matter which way you do it, show your work, do the one that makes sense to you. Part D, find the probability that the person doesn't read either paper. If they don't read either paper, then this is the probability of neither. If you want to get fancy and use more specific symbols, you can, but it's okay just doing that. Probability of neither, Venn diagram, 40%, or not New York Times and not USA Today, 40%. So that's where that's coming from. All right, on to page 6. So what I'm going to ask you to do on page 6 is work through these questions on your own. Practice them, see how you do. Pause the video if you want to just go through number 50 and 54 first, and then come back, and then 56, and then come back. You could do that, but I'm going to go through all three of these in this next part. So in number 50, the first thing I want to do is get all the totals. They're selecting one senator at random. What's the probability the senator is a Democrat? So total for the Democrats, 60 out of 100. Just use notation, probability of D. That's pretty obvious that D stands for Democrat. Female, probability of a female, 17 out of 100. Female and Democrat, so I'm looking for the intersection of female and Democrat, 13 out of 100. And female or Democrat. So you can use the formula. You could do what I just said on the previous page. Female or Democrat means they're female. They're just female, they're just Democrat, or they're both. So I'm really adding those three up. If I add up those three, I'll get 64. Or if I use the formula, I'll get 64. They want you to construct a Venn diagram, so you're just using those inner four numbers to get that. So start with the intersection for 4, because now they're talking Republican and female. There's 4. 47 are neither female nor Republican. And then you have 36 that are Republican but not female. And you have 13 that are female but not Republican. Then they give you the symbols, probability of R union F, that just means or. That means one or the other or both. So you can just sum up those three numbers, or you can use the formula. And then C, not Republican and not female. That's going to be the 47. Interpret this. So B, the interpretation, I didn't write it down, is the probability that somebody is Republican and female. And C, the probability, B is probability they're Republican or female, and C is the probability they're not Republican and not female. All right, 56 is a little tricky as far as setting up the Venn diagram, just because it's not as easy to just use complements here. And here's why. You have 40% of students use a Mac and the rest use PCs. So instead of just doing Mac and not Mac, I just did Mac and PC. They're still complements, they're using one or the other. And then 67% of the students were undergrads, the rest were grad students. So I did undergrad and grad. You could do undergrad and not undergrad. It just makes it a little trickier to kind of think about this. Okay, 23% of students used PCs as their main computer. So here's what I know. 67% were undergrads. I filled that in. 40% use Macs. I filled that in. And they said 23% were grad students who used PCs. So this is like not undergrad and not Mac users. So that's how I started the table. And then the total probability is 1. It will always be 1. Again, you notice me changing the decimals from percents to decimals. So at this point, I can fill in the complement. 33% of people are grad students. 60% of people use a PC. And you can fill in the rest of these numbers just using some simple math. In part B, they want you to find the probability that a randomly selected student is a grad student and uses a Mac. So intersection, grad student and Mac, 0.1. Part C, what's the probability that they use a PC or their undergrad? PC or undergrad. So that means just PC, just undergrad, or, just PC is the 23%, just undergrad is the 30%, or both. Or you can take the formula, probability that they use a PC, 60%, plus the probability they're an undergrad, 67%, minus the probability that they're using a PC and they're an undergrad, the intersection, and that's going to give you 0.9 as well. So I hope that this video made sense. At this point, what I want you to do is you're going to do page 7. That's your graded exit ticket. You're going to tear that off and you're going to turn that in to whoever's filling in for me today. And then the remainder of the block, if you do have time, you can go and start the Desmos work for section 5.2, please. I look forward to seeing you on Wednesday.